So it's very simple, really. The web is full of information. There's a lot of information in various forms, but mostly in forms that are made for humans to read. So you go on the web, you search on Google, you find a document, and the document will tell you something about something. And there might be a lot of different documents telling you different things about something. The thing with that being made for human form, it means that then it's up to you to take all this information, integrate it, and try to understand it and put it into something. And if you ever wanted to write a computer program, write an application, make something out of this information, you will have to encode it, you will have to make it into a way which is readable and understandable by a machine. The idea of the semantic web is to do that before it gets on the web, is to encode the information that might be in web pages or in anything else into directly in the way it's present on the web, which means to basically use the web not only as a medium to share documents, which are human readable, but as a medium to actually share data, share information that can be used by programs, which means also that because it's on the web, these informations can be connected. In the same way documents are connected through hyperlinks, you can connect information through the web that when it's directly published there, which means information about me, for example, can be connected with information about the university in which I live, or with information about my friends, with information about any other things like articles I have written, and all of that being directly accessible, which means we can write applications that use this information directly out of taking it out of the web, and put some and use this information in connection. But also that means that if you want to put information on the web, you can already connect it to information somebody else may have put. So one of the key use cases for that, for example, is DBpedia. It's this semantic web way of representing the information in Wikipedia, which means you can, if you want to publish information yourself about a particular topic, then you can relate it to the information which is already known in Wikipedia about it, and somebody else might write an application that uses both your information and the one there. That is following the principle of linked data, which is the most basic representation of the semantic web. It's called semantic web because one of the key original ideas is that for all of this to work, there need to be some meaning associated to this information. There need to be a way to represent what the information actually means, because it is going to be in different places and contributed by different people. So there have to also be a way to share, again through the web, what you are putting on the web actually means. What are the concepts that are related to? What are the relationship? What do the relationship actually signify between different objects? And to have a way to represent this knowledge about the information you are producing, so that whenever you make a connection, this connection can be meaningful and can be actually exploited using technologies such as ontologies and knowledge representation and automated reasoning to make the whole thing actually work for software agents, so that if you then go on the web, you have the ability to just obtain the information already integrated and already in a meaningful way, and you don't necessarily have to go through all the different web pages and all the different websites to understand how to do that yourself. There are many answers to that. Somehow, what is interesting is that there is a step before the semantic web can improve the tools like digital repositories, which is, so far, it is still very much a developer tool. It's still very much a technology tool. So there is an element that digital repositories should start by publishing the information they have in semantic web and linked data formats, so that the benefits can be shown. But then once you do that, once that happens, there are many, many ways in which it can be helpful. A simple one is that as soon as that happens, because of the nature of linked data and the semantic web, then the information in the digital repository is not anymore limited to what is in the system. It means you can start being able to connect all this information to others, which means it gives you both a way to enrich the information you have in your repository with other information, and a way and new entry points from other information systems, from other digital repositories getting into it. So there are many examples of that. One of my favorite, not only because I developed it, is this system called DiscoU, which is a system to try to find open educational resources from the Open University in the UK, so from one digital repository, based on a TV program in the BBC. And this is enabled because the digital repository of the Open University produces linked data and semantic web data, and the BBC produces linked data and semantic web data about their TV programs, which means the connection between the two things can be made. And that's one of the key things for me, is this connection enables people to find and explore resources without being limited by the fact that some of the resources are in one system and some of the resources are in another system. In other examples, they include, we are currently working in a project called the Listening Experience Database. It's a very interesting project with arts historian, and what they are doing is collecting information about listening experiences, which is somebody describing that they have listened to music. And they're collecting all sorts of information about the place where it is. There is no limitation. It can be in Paris, in India, wherever you want. The time, who is a listener, and what was the music, how the music was performed, and any kind, and where we find the information, the evidence that this person was listening to this music. This is a very valuable resource for art historian in music, because they can understand the perception of different musics in different places at a different time. They can understand what influenced what people listen to and what they think about what they listen to, all that sort of things. But somehow it's also a very challenging project, because trying to figure out what to ask users who describe a listening experience and ask them to put all this detail is extremely difficult. But so the approach we have been taking is exactly this semantic web one, which is the idea that because a lot of the information about all these different objects is already available as machine processable information outside, we only have to ask the people contributing to the database to give us the entry point, to tell us this is about the Fourth Symphony of Beethoven. And then we know the composer, we know when it was composed, we know everything out of taking the information from somewhere else. If they tell us it was in Paris, we know where Paris is, we know, and we can connect this information about Paris with every other listening experience that have happened in the same place. So there is this idea that as soon as you contribute to the semantic web, then the information, the small bit of information you contribute, is enriched by everything else you connect it to. Every other bit of information about Paris is available to you without you having to collect it, because it's just directly there. And that's, for me, it really the key. The semantic web is like an enormous knowledge base to which everybody can contribute and out of which everybody can benefit. You end up sharing your knowledge base with everybody else. That's a very interesting question, because that's one I've been debating a lot with a lot of people in learning analytics. And because somehow there is a bit of, or at least in my view, there is an aspect of learning analytics which is so far it has been done in a very opportunistic way. Basically, I summarize learning analytics as data analytics related to learning activities. Now, if you look at a lot of the research right now, it is about using data that come out of educational systems, like virtual learning environment, personal learning environment, and university systems in general, logs of this, all that sort of things. And what I say, that's why I'm saying this is opportunistic, is because somehow the research is guided by whatever we already have available, whatever is easy to obtain as data, and also about whatever we can easily control as educational model. In some way, there is a lot of research, for example, on dropout and success rate at degrees. What I don't like about this is that this is not learning analytics, it's education analytics. It's analyzing what activities happen within an educational program or an educational organization or something which is kind of clearly defined as educational program. And this notion, for example, of success is mostly meaningless when it comes to learning. Being successful at a degree doesn't mean you have learned. So learning the processes and learning the activities that make a student good at succeeding at a degree are not learning, is not about analyzing learning processes. It's about analyzing how you become good at a degree. So it's why we have this new project called AFL, Analytics for Everyday Learning, where really what we want to do is look outside of the educational programs and outside of the educational institution and look at where learning actually mostly happens. Well, it does happen in universities, but I would say a very large part of learning happens on social media, or it happens on YouTube, or it happens on Wikipedia. It happens in any kind of interaction you might have, online or offline. I mean, of course, we are only going to be able to look at online activities, but it's this idea that if we look at all the online activities that a student or a learner or anybody might have, amongst all of these, there are things that are learning activities. And a large part of them are not learning activities happening on a virtual learning environment of a university. There are things happening somewhere else. And somehow, that's also a way to say what we want is to understand how learning happens, not how education happens, but how you can, by the use of resources and by the interaction you have with other learners, with people who might or might not be formally educators, but that somehow act as contributors to what you do, in whatever settings you might be, how this makes you learn, and what are the behaviors that makes that happen. And somehow we do expect that, by looking at these other forms of learning, we can make learning analytics even in the kind of more current form more efficient. If we can look at how people use YouTube and Facebook in their formal education program, we will be better able to predict and understand how well they are doing. But the real objective is understand how to make the web a better learning tool, and that's the web globally. So somehow, any data about activities related to learning has to be taken into account when analyzing learning behaviors, because otherwise there is a gap, there is something missing. You are not analyzing the full picture, and somehow, if it is not in an educational program and if it's not there, it doesn't really matter. The important thing is we want to understand how learning happens, how the web can be better at supporting learning, and also how the learners can be more effective at using web resources in order to learn. To learn. So it's very ambitious, because the main challenge, obviously, is the main reason why learning analytics has taken this opportunistic approach of taking whatever data is available is because the data is available. And if it's an educational system, it's about learning. Taking all the data from social interactions on the web of anybody makes it very challenging, because it might be anything. It might not be, it's recognizing what in that captures a learning process, which is really the big challenge. It's a very ambitious project because we want to look at learning as it happens. And there is a lot of connection with the semantic web, in a sense, because this is about trying to make sense, to understand how to represent and encode the activities that happen online as learning activities. How can we make this data about whatever somebody does something which is processable by a software agent which aims to understand learning behavior And that's a really, for us, it really is a key thing, making sense of all of this data so that we can analyze it and interpret it automatically as a learning pathway, as a learning behavior, as a learning journey for the student. The interesting thing is also that this particular kind of set of data, this analysis we can do, will directly benefit the learner, in a sense that it is a way to say, this is currently the way you are using the web to learn. This is the way your behavior. And out of that, we can recommend other resources, we can recommend other ways, other practices, maybe from others or simply from understanding what is happening, so that, as I said before, it's not only the web that becomes a better learning tool, it's the learners who become better able to use the web as a learning tool, and somehow not have to go to the university tutor anymore. That's an interesting question, because I don't think it will ever happen.
No.
In a sense that you will always need to have an interface to humans. And in a way, one of the key challenges for semantic web technologies is that there is a point at which they become too complex for humans to find them easy to use. And somehow the keyword search of Google is still, is going to stay for a long time, simply because this is a simple way to search. So somehow I don't think you are ever going to say be able, or that searching semantically into Google is going to become the unique way of doing anything. What can happen is Google can use the semantics of the keywords and can try to improve the interaction and improve the way the results are given to you or provided or visualized. So by using these semantics, so that again the effort is not on you, it's on Google to try to make it from your two keywords to try to understand exactly what you mean. This is already happening quite a lot, in a sense that it's not only this little box, but Google has recognized that you are looking for somebody, and then the somebody gives you all the information. If you right now type into Google what to do in Barcelona, it's not going to give you a list of web pages, or not only a list of web pages, it's going to give you a list of touristic attractions in Barcelona, because it can interpret what you do and use machine processable information to know that Barcelona is a city, and that it's in a certain kind of geographical area, and that there are a number of touristic attractions that are located within this space. This is already querying Google semantically. The trick is not to complexify, not to even change the interaction you have with it, but make the result more clever and make the processes that get to this result more clever. So I think this is going to increase. And it also means that there might be many alternatives to Google that will start kind of, not necessarily alternative in the sense that other applications or other search engines that will try to do more semantically, but more specialized applications that will use the semantic web and some form of smartness on the basis of the information to help you find things easier. And you already see that. Tools to understand how to use transport, or to help how to use transport, tools to help how to find a restaurant, to tell you what music you might want to have. All of these are the result of doing very specific semantic queries to a set of information which are represented in a machine processable way. And that's really where where it's going, in a sense that it's kind of everything can be mediated with simple interaction and some cleverness, because the information is not only just web pages. So if it's not only web pages, then you still query it, but what you get is something richer. To be honest, my answer is I don't know.
Okay.
I know that Google used some semantic web related technology in the knowledge graph, and Facebook does too. Now, it would be really interesting to see whether Google is going to start searching into Facebook as a knowledge base, or as a set of documents? I currently I don't know. This is a very interesting question. Actually, I'm going to follow up. But somehow is if the idea from Google is that they are going, search means that they are going to index Facebook as a set of web pages, clearly they are missing a trick. So I suspect this is not what they are going to do. What they are going to do, again, I'm kind of extrapolating, is integrate the information Facebook had, and which is already in machine processable format too. I mean, Facebook has been using these technologies to, for example, to be able to do more complex queries. Like you can ask which of your friends like a certain thing, and that's a semantic query. So using this Facebook as a knowledge base to be able to answer something, to in Google be able to answer something more interesting, including, for example, if that means that you end up being able to say what to do in Barcelona, and a follow-up query, who in my friends have been to any of these, that starts sounding like a really interesting use case, and a really interesting way in which the semantic web is just slowly getting into your life without you even noticing it. It's just that things get more clever.